All right, welcome back. We're going to do Unit 2, Lab 3, and this is making decisions. So, first thing we're going to jump into is predicates, and we've used these before. So, predicates are reporter blocks that functions, and their functions that always report back Boolean values, which means they're true or false values. So, basically, it comes across the code and it compares it. Is this a true value or is this a false value? And then it decides which path that program will run. So in Snap, these predicates are usually represented with hexagonal blocks. So if you look over here, these are six-sided blocks, and that basically indicates it will be a predicate. So they use statements such as if else, and repeat until. So think back. Let's take a think and see if we can come up with some examples. So one example I can think of is our shopping list that we did earlier. For our shopping list, we said if the item is already on the list, then say it's already on there. If it's not, then add it to the list. That's an example of a predicate where it's asking a true or false statement. Is it on the list or is it not? Is the answer already on the list or is it not? And then it takes two different paths. So we have a repeat until, and we have an if and if else. And basically it decides when to do something. So some vocabulary to go over is range and domain. So in math, usually domain is where you start. It's the input to the function, and range is the output. So similar to computer science, the input type, often called the domain in programming, of a function is the type of data that is accepted into the input. So think of if you come across a math problem, usually you only want to accept numbers as inputs, not letters, typically. And then we come across output type, often called the range of a function, is the type of data that it reports as an output. So as we go to the next part, along with abstraction, these two ideas are among the most important in computer science. If you get that in the habit of using them in your thinking, you'll have many fewer bugs in your program. And it's because you'll automatically double check that the output type of the reporter matches the input type of the block in which you're trying to use. So we're going to move on to the next section. Predicates ask a true or false question such as, is the random number 3? Or for example, we have our follow the leader that we turned in a little bit earlier. So is the sprite touching the sprite leader? So is the following sprite touching the leader sprite? And then we said if it does, stop the program. Continue on in a different path. So every if block has two separate scripts. Basically, if the statement's true, you're going to report the first one. If it's not true, report the second one. So right now, you're going to go ahead and open up Snap and start U2L3 predicates. And if you recall, in Unit 1, Lab 5, this is where it was follow the leader, where you basically had one sprite follow another sprite. It said, forever, go to where the mouse is pointed. And that would have been for the leader sprite. The follower one would say, go to the leader sprite and then maybe delay it by a predetermined amount. So it says we're going to do something kind of similar. So now use the one or more of the following relation operations to create a script that lets you use the mouse to write on the stage in two colors depending on where the mouse is on the stage. So this reminds me a lot of the Pong game, where we said if the Pong ball goes past this imaginary line, it's going to stop and then restart the game. And we said the imaginary line was, I believe, over here. It was the X value of 2, I think we said 39. This one looks like it's saying if the Y value of the sprite is above 0, make it red. If it's below 0, make it blue. So let's go ahead and pull out some blocks that could be pretty useful. All right, so I made the code, and right now it looks like anytime that pen goes above 0, it is turning blue. Anytime it's below 0, it is red. And it looks like sometimes you can get it to go pretty high above that 0 before it changes. So maybe the script's just delayed, the mouse is just delayed just a little bit. So here's the blocks that I used, and you can recreate your version of something similar. So we come across a tip about the AP exam. So it's saying there's 5 relational operators, which we're looking at equals, greater than, less than, greater than or equal to, less than or equal to, and also not equal to. So next part is we actually go into the not equal to and see why it's a little confusing sometimes. So the not equal to and reports false if the two inputs are equal. So otherwise, reports true if they're not equal to. So for example, if we say does 3 not equal 3, that is false because 3 does equal 3. That would be a true statement. Does 3 equal 4? It does not, so it's not equal to. So that's a true statement. And you know what? I'm going to throw some code in here to make sure that it is only following the mouse when it's being held and drawing when it's being held. And some blocks that I threw in here so far is pen up and also when I'm clicked. So that should be enough for you to have this pen, for you have this sprite only go when you click on them. And you know what? I was not super paying attention for that, but basically here is when the mouse is down, and you can incorporate that into the code instead of when I'm clicked. And for the last part, we're going to go into a little vocab. So sequencing, selecting, and iteration. So selection means you're deciding or selecting which part of the algorithm to run based on whether the conditional is true or false. So every algorithm can be constructed using sequencing, which is following steps. And a lot of what we've done in the first part of our units were sequencing is basically what do you want to first happen? What do you want to happen next? Usually you ask a question first, or you have a statement like introducing somebody first, and then it goes into maybe a question, and then it might go into some type of decision the sprite makes. And you have selection and you have iteration. So iteration is repeating. So think of when we were doing the search on the shopping list and deciding which item to delete. It had to do an iteration, it had to repeat over and over again until it found that item that matched what we were looking to delete, and then it deleted it. I think that's it for now. I will see you on page 2.